Tuesday, 5th November 2019. Mathematics paper 1, higher tier. Answer all questions. You must show all your working, and total mark for this paper is 80. Find the lowest common multiple of 108 and 120. So you can break down 108 by doing a factor 3. 108 54 times 2, and we color the 2 or circle the 2 because it's a prime number. 54 is 3 times 18. We circle the 3, it's a prime number. 18 is 3 times 6, and 6 is 2 times 3. So we color all the prime numbers. So 108 is the same as 2 times 2 times 3 times 3 times 3. We do a factor 3. A factor 3 for 120. So 120 is the same as 30 times 4. And we can break down 30 times 4 as 6 times 5. 6 times 5 as the 5 is a prime number, and we can break 6 as 3 times 2. So we can write 120 as 2 times 2 times 2 times 3 times 5. Now we look for the numbers, the factors, the prime factors which are found in both lists. 2 is found in both, another 2 and 3. We multiply those ones first. 2 times 2 times 3, that will give us the highest common factor. And then we multiply by the rest of the numbers, which are 2, 3, 5, and 2, 3, 3, and 5. So it would give you 1080. And the way I multiply those numbers, I do the ones in yellow first. 2 times 5 will give me 10. And then 2 times 3 times 3 times 3 will give you 54. Because I first of all do 3 times 3 times 3 gives you 27. And 27 times 2, 54. And then you do 54 times 2 is 108. And 108 times 10 is 1080. That's how you do it without a calculator. Question number 2. There are 60 people in the choir. Half of the people in the choir are women. The number of women in the choir is 3 times the number of men in the choir. The rest of the people in the choir are children. The number of children in the choir is 2. The number of men in the choir is n is to 1. Work out the value of n. You must show how you get your answer. So to do this type of question, we need to find the number of men. Because there are 60 people in the choir, half of them are women. So half of 60. 60 divided by 2 is 30. So 30 are women. So, but the number of women in the choir is 3 times the number of men. So it's 30 women divided by 3. It gives you 10. So there are 10 men because the number of women, 3 times 10 is 30. The number of women is 3 times the number of men. We need to find the number of children. If we know the number of women and the number of men, we subtract that from the total number of people to get the number of children. So there are 60 people, 30 women, and 10 men. So 60 minus 30 is 20, is 30. 30 minus 10 is 20. So there are 20 children. Now we want to find that value for n. We use that ratio. The number of children in the choir is 20 is to the number of men in the choir is 10. We simplify. Divide by 10 on both sides. 20 divided by 10 is 2. And 10 divided by 10 is 1. So the ratio is 2 is to 1. So that means the number of children in the choir is to the number of men is 2 is to 1. So n is 2. Question number 3. Work out 1 and 3 over 4 times 1 and 1 over 3. Give your answer as a mixed number. We need to change 1 and 3 over 4, which is a mixed number, to improper fraction. So you do 1 times 4 plus 3. 1 times 4 plus 3 goes in the numerator, divided by 4. That's 7 over 4. 1 and 1/3, change it to improper fraction. 1 times 3 plus 1 gives you 4 divided by 3. So now we multiply 7 over 4 times 4 over 3. The 4 would cross out, cancel 4 from the top and the bottom. So you cancel 4 from the top and bottom, and you're left with 7 over 3. 7 divided by 3 is the same as 3 plus 3 is 6 plus 1 is 7. So there are 2 3's. 2, 3, remainder 1 over 3. 2 and 1 over 3, because 7 divided by 3 is 3, 3, and 1. 3 plus 3 is 6 plus 1 is 7. So it's 2, 3, remainder 1 over 3. Question number 4. Use a ruler and a compass to construct the line from the point P perpendicular to the line CD. You must show all your construction lines. So this is the process to draw a perpendicular from a point of a line. So you have a point there and you have your line CD. So the steps are: place your compass point on P and swing an arc of any size across the line twice. So you want to do that so that you get the arc. It crosses it at 2 points. That's the process. Number 2, place a compass point on one of the 2 locations where the arc crosses the line and makes a small arc below the line on the other side where P is not located. So you put your compass at that point there, and then you will make this arc. And without changing the span of the compass, place the compass point on the other location where the first arc crosses the line and make another small arc below the line. So you change it to the other point and you do another arc. So you get the 2 arc crosses like that. And the 2 small arcs should be intersecting on the other side of the line opposite point P. So you put the compass there and make this arc. Take the compass, put the next point and make the arc. And then use a straight edge, connect the intersection of the 2 small arcs to point P. So you join them, that point and the 2 arcs. And that's what you would get when you do the process. Question number 5. The diagram shows triangle ABC. ABC. ADB is a straight line. I've highlighted ADB in pink. The size of angle DCB is to the size of angle ACB is 2:1. Work out the size of BDC. Now, the first thing we want to do is the angle we want to find. I've colored it in yellow. We want to find BDC. So let's find the angle ACB. ACB is this angle I'm highlighting, total angle ACB. If you see the triangle, 180 degrees. So to get ACB, 180, take away 75 and take away 51. That gives you 54. So ACB is 54 degrees. And we want to share it between those two, between ACD and DCB. So to share it in the given ratio, 2:1. So we'll do 2 plus 1. It gives you 3. 54 divided by 3 is 18. So it's 18 parts. So now it is 18 times 2 it gives you 36, because it is 2:1. 18 times 2, it gives you 36. So the angle is 180 minus 51 minus 36. It gives you 93. So 180 minus 51 minus 36, it gives you that angle there, 93. Question number 6. 4 red bricks have a mean weight of 5 kilograms. 5 blue bricks have a mean weight of 9 kilograms. 1 green brick has a weight of 6 kilograms. Donor says the mean weight of the 10 bricks is less than 7 kilograms. Is donor correct? You must show how you get your answer. So the first thing I will do is find the total weight of the 4 red bricks. There's 4 red bricks and the mean weight is 5. So 5 times 4 is 20. So the total weight of the 4 red bricks is 20. Next thing is find the total weight of the 5 blue bricks. Total weight of the 5 blue bricks is 5 bricks times 9 kilograms. It gives you 45 kilograms. Now, we want the total weight of all the bricks. So we want to add the red plus the blue plus the green. So the red is 20, the blue is 45, and the green is 6. So 20 plus 45 plus 6. That gives the total weight of all 10 bricks as 71. And if you find the mean, 71 divided by 10 is 7.1. So the mean would be 7.1. So is donor correct that it's less than 7 kilogram? No, because it is 7.1. 7.1 is not the same as is less than 7. So the answer is no, she is wrong. 7.1 is 1.1 more than 7. You can say 7.1 is 1 more than 7. Or you can say the total weight is 71 and not 70, because 71 divided by 10 is 7.1. Question number 7. Simplify p squared to the power 5. You multiply the power 2 times 5. 2 times 5 is 10, so it's p to the power 10. Simplify 12x to the power 7 y cubed divided by 6x cubed y. So we do 12 divided by 6 is 2. X to the 7 minus x to the 7 and x to the 3. So 7 minus 3 is 4. And y cubed divided by y1, y to the 3 minus 1. So 3 minus 1 gives you 2. So what we're doing is we are subtracting the powers for x, 7 minus 3. Subtract the powers for y, 3 minus 1. And then divide the numbers, 12 divided by 6. So your answer would be 2x to the 4y squared. Question number 8. The accurate scale drawing shows the positions of port P and the lighthouse L. So that's the port P and that's the lighthouse L. Scale 1 centimeter represents 4 kilometers. Alina sails her boat from port P on a bearing of 070 degrees. She sails for 1.5 hours at an average speed of 12 kilometers per hour to a port Q. Find the distance in kilometers of port Q from the lighthouse. So what we want to do is we want to first of all find out where port Q is. And to find where port Q is, we need to draw the bearing of 070 degrees. So because it says an accurate scale drawing, so we need our protractor to go and measure the angle of 70 degrees. So I'll bring it there and we measure the angle of 70 degrees. So with the protractor, we use it to measure the angle of 70 degrees. So that's how you put the protractor. The middle point of the protractor at the corner where 0 is, and you start from 0 to 70 degrees and you mark it, and you take the protractor away. You draw the straight line PQ. But how long is this line going to be? We don't know. But we just draw the line as far as possible, and we're going to calculate how long that line is going to be. It tells us that she sails for 1.5 hours at a speed of 12 kilometers per hour. So we want to find the distance. Distance is speed times time. So work out the distance PQ. The speed is 12 kilometers per hour and the time is 1.5. And you see that in the question, 12 kilometers per hour and the time is 1.5. So 12 times 1.5 gives you 18 kilometers. Now, we cannot draw 18 kilometers on the paper. That's too long. So we use the scale. The scale says 1 centimeter represents 4 kilometers. So what would 18 centimeters represent? So it'll be 18 divided by 4. It will represent 4.5 centimeters. So we will use the ruler and we will draw 4.5 centimeters distance. So when you turn your ruler, you will put it and you will draw 4.5 centimeters and you will start from there, 4.5 centimeters. And when you mark that, that will give you the distance where Q is. Now, the question says, find the distance in kilometer of port Q from the lighthouse L. So we want to find the distance from Q to the lighthouse L. So we would use the ruler. We use our ruler to measure the distance from Q to the lighthouse. When you use your ruler to measure distance from Q to the lighthouse, I've zoomed in, so my answers will not be correct. You measure the distance from Q to the lighthouse, and then you would convert it back to real using the scale. 1 centimeter is 4 kilometers, and you will multiply it by 4, and your distance would be between 20 and 23. So you get roughly 20 kilometers. And that will give you the distance from port Q to the lighthouse L. Part B, find the bearing of port Q from the lighthouse. So we would use our protractor now. This time we want to measure the angle. From port Q, find the bearing of port Q from the lighthouse. So we're starting from the lighthouse. Is this angle there? This angle we're putting the red. But to measure that angle is quite tricky. So we would use the protractor and measure the smaller angle. So if you turn your protractor and you measure this smaller angle, you will get this smaller angle in there to be 30 degrees. Because that is 30 degrees and you know the complete circle is 360. So 360 minus 30 would give you the other angle. So you measure the smaller angle, which is easier, and then you subtract it from 360 degrees to get 330 degrees. So that's what you will get. You will get 330 degrees and 20 kilometers. Question number 9. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in this 18 minutes? So I've put on the right-hand side the formula that you need to know. Speed is distance divided by time. And you want to find the distance. The distance is given by the speed times the time. So we need to change the time to hours. We've got 18 minutes. We know that 60 minutes is equals to 1 hour. So 18 minutes would be 18 out divided by 60 of an hour. So the distance is the speed, which is 72, times the time, which is 18 over 60. And that'll give you 21.6 kilometers. David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? You must show your working to get your answer. Because in the calculator, you can use the calculator to convert from kilometers per hour to meters per second. But here, you need to show the working. So what you want to do, you can convert 20 meters per second to kilometers per hour and compare them, or you convert 72 kilometers per hour to meters per second and compare them. You want them to be in the same unit, either meters per second, all of them, or kilometers per hour. So what I'm going to do, I'm going to convert all of them to meters per second. So 20 meters per second stays the same. I don't change it. I only want to change 72 kilometers per hour to meters per second. Kilometers means times 1,000. So change 72 kilometers to meters, you times 1,000. Hour, 1 hour is 60 minutes, and 1 minute is 60 seconds. So it's 60 times 60. So 72 kilometers will be 72 times 1,000 for meters. An hour will be 60 minutes times 60 seconds. Now you simplify. If you put that in your calculator, that will give you 20 meters per second. So is David correct? The answer is no. 72 kilometers is the same as 20 meters per second. So they are both the same. So David is not correct. So that's the complete answer for question number 9. 21.6 kilometers for part A, and the answer is no for part B. Question number 10. The cumulative frequency table shows information about the times in minutes taken by 40 people to complete a puzzle. On the grid below, draw a cumulative frequency graph for this information. We've got a cumulative frequency already. So we are using the upper class boundary. I've highlighted it all in pink. So the first point we plotted is 45. 45. So 45, you mark the point there. The next pair of point is 60, 25. 60, 25. So 60 up and 25, you mark it there. The next point, 80, 35. 80 and 35. So 80 and 35. And the next point, 138, 100 and then 38. And the last point, 120 and 40, 120 and 40. So if you mark that point, and we would join all of them with a curve. Don't use a ruler. You join a curve, and that shape of that curve is called an ogive shape. So that's the cumulative frequency curve. Part B, use your graph to find an estimate for the interquartile range. The interquartile range, we use this formula. Lower quartile is Q1, upper quartile is Q3. So interquartile range is Q3 minus Q1. Or you can use these other symbols. Upper quartile UQ minus lower quartile. So we're going to look at those on the graph. It was 66 minus 44, which will give you 22 for the interquartile range. But let me show you on the graph how we got those numbers 66 and 44. So on the y-axis, which shows the cumulative frequency, the y-axis, it starts from 0 and goes up to 40. We want to divide it into 4. So there's 10, 20, 30, and 40. So we divide it into 4. So the first one is the lower quartile, the boundary for lower quartile. The next one will be at 20, which will be for the median. The next one will be at 30, which will be for the upper quartile. So we would follow the line from 10 to where it meets the curve and down, and you will get 44. And you will follow it for the one at 30, follow the pink line, and you get 66. So the interquartile range is 44, 66 minus 44. So from the graph, interquartile range is given by this 66 minus 44, which is 22. Part C, use your graph to find an estimate for the probability that this person took between 50 minutes and 90 minutes to complete the puzzle. So you would get 37 minus 15 divided by 40, which is 22 over 40. And I'll show you how you get 37 and 15 on the graph. So on the graph, from the point 50, you draw a straight line, and I hope you can see that light green line there. You get 15 there. And for 90, you draw a line that goes up to where it meets the cumulative frequency curve. You move to the y-axis, and that is where you get that 37. So that's where you get the 37 minus the 15, and that gives you the 22. So that's the complete answer for that question. You have the cumulative frequency curve, the interquartile range, and then the probability. Question number 11. There are P counters in a bag. 12 of the counters are yellow. Shafiq takes at random 30 counters from the bag. 5 of these counters are yellow. Work out an estimate for the value of P. So we want to use cross multiplication. I've put it on the top right there. The method of cross multiplication, it says if A divided by B is equals to C divided by D, then A times D is equals to B times C. So what we want is Shafiq takes at random 30 counters from the bag. 5 of these 30 counters are yellow. So 5 out of 30 is the same, equals to 12 out of P, because we know there are P counters and 12 are yellow. P counters, 12 are yellow. And you take 5 and 30 counters out of 30. So you cross multiply 5 times P, 5P, 30 times 12 is 360. 5 times P is equal to 360. You divide by 5. P is 360 divided by 5. It gives you 72. Question number 12. T is equals to Q over 2 plus 5. Here is Spencer's method to make Q the subject of the formula. 2 times T is equals to Q plus 5. Q is equals to 2T minus 5. What mistake did Spencer make in the first line of his method? So that's the first line of the method. All 3 terms should be multiplied by 2 and not just 2 of them. So these 2 should have been multiplied by 2T there, this times 2, this times 2. So that's the mistake he made. All 3 terms should be multiplied by 2. And the 5 should be multiplied by 2. That's another way to say it. You should have multiplied the 5 by 2 as well. Or you can say it should be 2 times T plus Q plus 2 times 5. So you can write one or the other and you'll get the mark. Question number 13. Write 5 over x plus 3 plus 2 over 3x as a single fraction in its simplest form. So we can use the upside down table method. So we have 5 times 3x, you write that down, plus 2 times x plus 1, 2 times x plus 1, divided by x plus 1 times 3x, which is there. So you're following that pattern like that. the upside down table. If a table is like that, the upside down table is like that. So you're multiplying 5 times 3 plus 2 times 1 divided by 3 times 3x times x plus 1. Now you multiply 5 times 3x is 15x. 2 times x is 2x. 2 times 1 is 2. Collect the like terms. 15x plus 2x is 17x. 17x plus 2 divided by 3x bracket x plus 1. And that's your answer. Factorize x plus y squared plus 3 bracket x plus y. So we can write x plus y squared. There's two of them, so write it twice. X plus y times x plus y plus 3 bracket x plus y. We look on the left term and on the right term. We see that x plus y is common. I've colored it in this green. X plus y is found in both of them. So we take x plus y out of the bracket. And what we are left with is x plus y for the first term and 3 for the second. So your answer is x plus y bracket x plus y plus 3. So that's the complete answer for question 13, A and B. Question number 14. The diagram shows a right angle triangle. All the measurements are in centimeters. The area of the triangle is 27.5 centimeters squared. Work out the length of the shortest side of the triangle. You must show your working. For question number 14, we are going to be using these two formulae. Area of a triangle is half times the base times the height. The base times the height. And the next formula we will use is the quadratic formula. Ax squared plus bx plus c equals to 0. And x is given by minus b plus over minus square root of b squared minus 4ac divided by 2a. So these two formulae will be used for that question. So to find the area of the triangle, half times the base, which is x plus 4, times the height, x minus 2. And that is equals to the area, 27.5. So half times the base, x plus 4, times the height, x minus 2, is equals to the area, 27.5. Now, we need to expand these brackets and derive a quadratic equation. So to expand the bracket using the first, outer, inner, and last method, x times x, it gives you x squared. X times 2 gives you minus 2x. 4 times x, it gives you 4x. 4 times minus 2, it gives you minus 8. And then, because we had a half there, it's 1 over 2. If we take the 2 to the right-hand side, it becomes times 2. 27.5 times 2, it gives you 55. And we take the 55 to the left, it becomes minus 55. And we're left with 0 on the right side. So 0.5 is the same like half. We take it to the right and times the 27.5. And that gives us 55. And we take the 55 from the right side, we minus 55 on both sides, or we take it to the left, and it becomes 0 on the right and minus 55. So we have x squared minus 2x plus 4x, it gives you plus 2x. Minus 8 minus 55, it gives you minus 63, equals to 0. Now we need to solve that quadratic. You can use the quadratic formula, which I've swapped in the number there, or you can just use factorizing. Two numbers that add to make 2, that multiply to make minus 63. Minus 7 plus 9, it gives you 2. Minus 7 times 9, it gives you minus 63. So you have x minus 7, x plus 9 equals to 0. So if x minus 7 is equals to 0, you write it like that. So x equals to 7. And if x plus 9 is equal to 0, so x equals to minus 9. So the length of the shortest side is x minus 2. So we would use 7. 7 minus 2 is 5. We do not use minus 9 because length cannot be negative. So the shortest side is x minus 2. And for x, we will use 7. 7 minus 2 will give us 5. Question number 15. Express 0.418 recurring as a fraction. You must show all your working. So we write x is equal to 0.41818. The 18 is the recurring part. If we multiply by 100, so become 100x will become equals to 41. You move it 2 decimal point from 1, 2. Become 41.8181 recurring. So if we write x is 0.41818 recurring, and we subtract these two, 1 minus 1 is 0. 8 minus 8 is 0. 1 minus 1 is 0. 8 minus 4 is 4. And the decimal point stays where it is there. And you have 1 minus 0 is 1. 4 minus nothing is 4. 100x minus 1x is 99x. So we have 99x is equals to 41.4. So it's times 99. We take it to the right hand side, it becomes divided by 99. So 41.4 divided by 99. And what you can do, you can times by 10, divide by 10 is the same like times by 1, and it doesn't change. So you get 41.4 times 10 is 414, and 99 times 10, it gives you 990. Question number 16. Rationalize the denominator of 22 divided by square root of 11. Give your answer in its simplest form. Part B, show that square root of 3 over 2 root 3 minus 1 can be written in the form a plus root 3 over b, where a and b are integers. So for 16a, we will multiply by square root of 11 divided by square root of 11. Because square root of 11 divided by square root of 11 is like 1. So it's like multiplying by 1, and that doesn't change an answer. So 22 times square root of 11, it becomes 22 root 11. Square root of 11 times square root of 11 gives you 11. Because square root of 11 is like 11 to the half times 11 to the half. Half plus half is 1, so it's 11 to the 1. That's why you get 11. And 22 divided by 11 is 2. So your answer is 2 root 11. For part B, we will multiply by 2 root 3 plus, we'll change that to a plus, 2 root 3 plus 1. So root 3 times 2 root 3, so have 2 root 3 times root 3 plus root 3 times 1 plus root 3. In the denominator, 2 root 3 times 2 root 3, we'll write it there. 2 root 3 times 1 stays as 2 root 3. Minus 1 times 2 root 3, minus 2 root 3. And minus 1 times 1 is minus 1. So in the numerator, root 3 times root 3 is 3. 3 times 2 is 6. Because root 3 is the same as 3 to the half times 3 to the half. Half plus half is 1, so it's 3 to the 1. So it's 3 to the 1. 2 times 3 is 6 plus the root 3. In the denominator, in yellow, 2 root 3 minus 2 root 3 is 0. And 2 times 2 is 4. Root 3 times root 3 is 3. So 3 times 4 gives you 12. So 12 minus 1 is 11. So it's 6 plus root 3 over 11. So the A is like 6 and the B is 11. So that's your answer for question 16. 2 root 11 and 6 plus root 3 over 11. Question number 17. A and B are two similar cylindrical containers. The surface area of container A is to the surface area of container B is equals to 4:9. Tyler fills container A with water. She then pours all the water into container B. Tyler repeats this and stops when container B is full of water. Work out the number of times that Tyler fills container A with water. You must show all your working. So we have here what a formula or a table that we're going to be using this, where measure the length, it gives you a scale factor or the multiplier. And for the area, is the scale factor squared. For volume, is scale factor cube. We're going to be using this idea to do that question. So area scale factor is equals to length scale factor squared. And if we want to get the length scale factor, it will be the square root of area scale factor. So you want to find the ratio of corresponding lengths. The ratio is 4:9 for the area. So to get it for length, we have to do the square root. Because it's area, we have to do the square root to get it for length. So square root of 4 is to square root of 9. So the length scale factor will be square root of 4 is 2, square root of 9 is 3. So we are given area scale factor 4:9. To change it to length scale factor, we square root because area is squared. So we change it to square length scale factor. Now that we've got length scale factor, we have to change the length scale factor to volume scale factor. And to change length scale factor to volume scale factor, we cube the length scale factor because volume is cubed. So we have 2 cube is 8, 3 cube is 27. 3 times 3 times 3 is 27. So that means the ratio is 8:27. So how many times 8 goes into 27? 1, 2, 3, 8, 16, 24 plus 3. That gives 27. So you will do the first time. So work out the number of times Tyler fills container A. Container A is 8. So we'll do it the first time 1, second time to fill it, third time to fill it. And we have to do it the fourth time to get this remainder 3. So we'll do it 4 times. So Tyler will fill it 4 times. Question number 18. The function f is given by f of x is 2x cubed minus 4. Show that f inverse of 50 is equals to 3. So if we substitute, we have f of 3. It will give us 2 times x cubed minus 4. We put 3 in there. 2 times 3 cubed minus 4. 3 cubed is 27. 3 times 3 times 3 is 27. And 27 times 2 is 54. 54 minus 4 is 50. The functions g and h are given by g of x is x plus 2 and h of x is x squared. Find the values of x for which hg of x is equals to 3x squared plus x minus 1. Also, for question 18a, where f of x is 2x cubed minus 4, there's another way to do it. You can replace f of x with y. So you write y equals to 2x cubed minus 4. And you make x cubed x the subject. So take 4 to the left. So y plus 4 equals to 2x cubed. It's times 2, you divide by 2. Y plus 4 divided by 2 is x cubed. And to get rid of the cube, you find cube root. So cube root of y plus 4 divided by 2 is equals to x. Now you can swap x and y back. So you can write y equals to cube root of x plus 4 divided by 2. And you can replace y back with f inverse of 50. And if you substitute 50 for x, cube root of 50 plus 4 divided by 2, 50 plus 4 is 54, divided by 2 is 27, and cube root of 27 is 3. That's another way to show that for that question 18a. For 18b, g of x is x plus 2, h of x is x squared. So hg of x would be x plus 2 all squared. And x plus 2 all squared means x plus 2, x plus 2. So hg of x, so whatever you do, you take g of x and substitute it in place of x. So this x plus 2, it goes in place of x. So it becomes x plus 2 squared. You multiply this using the FOIL, first, outer, inner, last method. X times x is x squared. X times 2 is 2x plus 2x is 4x plus 4. Now hg of x is 3x squared plus x minus 1. So now what you do is your x squared plus 4x plus 4 from there is equals to 3x squared plus x minus 1. So we got the left hand side is equals to the right hand side. To solve it, we put everything to one side. So I always put everything to the side that has the bigger value for the largest x term. So this one has 3x squared. So I'll take this 1x squared to this side, to the right, put it in front there. Because it's plus x squared, it becomes minus x squared plus x. And I'll take this 4x to that side, it will become minus 4x. And I'll take the plus 4 to the right, it becomes minus 4. So one of the sides is 0. So 3x squared minus x squared is 2x squared. X minus 4x is minus 3x. Minus 4, minus 1 minus 4 is minus 5. Now you factorize this. You can use the quadratic formula, or you can use your calculator, the Casio calculator. And when you factorize, you get 2x minus 5, bracket x plus 1 equals to 0. So 2x minus 5 is equals to 0. Take 5 to the other side, 2x equals to 5. And you divide by 2. X is equals to 5 divided by 2, which is 2.5. Or x plus 1 equals to 0. Take it to the other side, 1 to the other side, x equals to minus 1. So you got two answers. X is minus 1 or x is 2.5. So that's how you do question 18b. You can use the quadratic formula, which I've put at the bottom there, and substitute in the numbers. And you will get 2.5 and minus 1. Question number 19. Given that 9 to the minus a half is equals to 27 to the 1 over 4 divided by 3 to the x plus 1. Find the exact value of x. So we're going to be using some of these laws of indices. A to the power m times a to the power n. You add the powers m plus n because the base is the same, a. So you add the top, m plus n. A to the power m divided by a to the power n. You subtract the powers because the bottom base is the same. A to the m times n, you multiply the powers. So we're going to be using some of them for solving this question. So the first thing to notice is that it's a 9 at the base there, 27 at the base there, 3 at the base. They are different numbers. So what do we want to do is to make all the base the same number. And what is the smallest number that is the same for all of that you can use? We use the smallest number, which is 3. So we change 27 to something that has 3. 27 is 3 to the 3, because 3 to the 3 means 3 times 3 times 3 is 27. 9 is the same as 3 squared. 3 times 3 is 9. So we will replace 9 with 3 squared, replace 27 with 3 cubed, and we leave the 3 to stay the same. That's the first thing we do. So now we notice that the base is all 3, 3, 3. Now we can start working with the powers. So we do 2 times minus a half. 2 times minus a half, the 2 would cancel with that, so you get minus 1 left. 3 times 1 over 4 is 3 over 4. And the x plus 1 stays the same, x plus 1. Now on the right hand side, if you put a line like that, that's your left hand side, and that's your right hand side. On the right hand side, we can put these two powers together because the base is 3 and 3. So it's 3 over 4. When you divide, you subtract. So it's minus, put that in bracket, x plus 1. So if we remove the bracket, so we are using this rule, this one, number 2 there, this law of indices. When you divide, you subtract the powers. So we've got minus x minus 1. So it's 3 over 4 minus x minus 1. Now, on the left side is 3 to the minus 1. On the right side is 3 to the 3 over 4 minus x minus 1. Since the base is the same, that means their power has to be the same. So that means the minus 1 has to be equals to the top on the right hand side. So we want to solve this equation now. We want x, so x is minus on the left. On the right, we take it to the left, it becomes positive x. And we take the minus 1 to the right, it becomes plus 1. So 3 over 4 minus 1 plus 1. Minus 1 plus 1 is the same as 1 minus 1, which is 0. So x is 3 over 4. Question number 20. The graph of y equals to f of x is shown on the grid. On the grid, draw the graph with equation y equals to f of x plus 1 and minus 3. The plus 1 means you move it to the left by 1, and the minus 3 means you move it down by 3. So you go left by 1 and down by 3. So I'm going to animate it there for us to see. So this is where we start, and you move it left by 1 and down 3. 1, 2, 3. So that should fit. So you move it left by 1. So let me show you what's happening there. We're going to move it left by 1 because x plus 1 in a bracket means plus 1 means you move it to the left by 1. That's why we put minus 1. Minus means go to the left by 1. And minus 3 means go down by 1. And the way to remember this is for x plus 1 is people who live together don't get on. So when it's in a bracket, x plus 1, you move it to the left by 1. So we started here, if you look at animation, and then we move it to the left by 1, and then we go down 3. 1, 2, 3, and that's where it ends. So that's what you do, and then you draw the new shape, and I've drawn it there in pink. You can see it. So this point has gone 1 and then goes 1, 2, 3. This top point has gone 1 and then goes 1, 2, 3. So you can have the new coordinates for where those points are. Point A minus 2, 1 lies on the graph of y equals to f of x. When the graph of y equals to f of x is transformed to the graph with equation y equals to f of minus x, point A is mapped to point B. Write the coordinates of point B. So what we're doing here is we start with f of x. The x is positive, and it goes there to f of minus x. The x is negative. So what's that new coordinate? What is going to be the change on this point A? So it's important to think of what's going to Sketch the graph of y equals to 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intercepts with the coordinate axis. The first thing we want to do is we want to complete the square. So 2 would factorize out, and you're left with x squared minus half of 8 is 4x, and half of 5 is 2.5. So the 2 stays the same, and we'll complete the square for what's inside that. So half of 4 is 2, so it's x minus 2 squared, and square the 2 and minus 2.5. So you have 2 bracket x minus 2 squared minus 6.5. Minus 2 squared minus 2.5 is minus 6.5. And if you multiply by the 2, it becomes 2 times x minus 2 all squared minus 13. 2 times 6.5 is 13. Now, from this, we can pick out the turning point. The turning point are 2 and minus 13. So this is the rule to get the turning point. If you have a quadratic ax squared plus bx plus c, after you complete the square, when it looks like this, a bracket x plus p all squared plus q, the coordinates of the turning point would be minus whatever that is, that p there. So minus p and q. So that's why we got 2 and 13 for the turning point. Next thing is to find the roots. The roots is where it crosses the x-axis. So that means y is 0. We solve that equation. We'll take 13 to the right. So have 2 bracket x minus 2 all squared equals to 13. It's times 2. We divide by 2. So 13 divided by 2 is x minus 2 all squared. We take the square to the other side. It becomes square root. From square root of 13 over 2 equals to x minus 2. And the minus 2 goes to the right. It becomes 2 plus or minus square root of 13 over 2. So there's 2 values for x, 2 roots. X is 2 plus 13 over 2. We use the plus first. And x is 2. We use the minus 13 over 2. So there are 2 places where it crosses the x-axis. Next, we find the intercept on the y-axis, where it crosses the y-axis. So we put x is 0. So when we put x is 0, 0 minus 2 squared times 2 will give you 8 minus 13. It gives you minus 5. So the y-intercept is 0 minus 5. So these are the information we use for recording the graph. The turning point, 2 minus 13. Intercepts on the y-axis, 0 minus 5. Intercept on the x-axis, 2 plus root 13 over 2. And 2 minus root 13 over 2, 0. So it's a U shape. It crosses. Intercept on the y-axis is 0 minus 5. It crosses the x-axis as 2 plus root 13 and 0. And also at 2 minus root 13 and 0. So it crosses the x-axis at 2 points and the y-intercept. So that's a sketch of the graph, and that's what you will sketch it in an exams. And another way to get the turning point, we had the function y equals to 2x squared minus 8x minus 5. We can do differentiation for those who have done differentiation. Find the turning point. Differential of y over x. When you differentiate 2x squared, you get 4x. When you differentiate 8x, you get 8. And at the turning point, the gradient is 0. Because if something is going down, it stops going down and it turns going up. So the gradient at that point where it turns is 0. dy over dx is 0. It's coming down with negative gradient. It stops and it starts going up. So it's negative gradient, positive gradient. At this point there, the gradient is equal to 0 because that's where it's turning point. So solving dy over dx equals to 0. That means 4x minus 8 equals to 0. That would give 4x equals to 8 and x equals to 2. When we know x is 2 for the turning point, we want to find y. we substitute the 2 back where we have the x. So we get 2 times 2 squared minus 8 times 2 minus 5. So that gives you 8 minus 16 minus 5, and that gives you minus 13. So the turning point is 2 and minus 13. That's another way to get the turning point. So you get the turning point by differentiating and solving the dy over dx equals to 0 to get x, and solve that value to get y, to get the turning point 2 minus 13. Or you can complete the square and use that formula to pick which one is the turning point. So that's what your graph will look like for question number 21. Question number 22. A, B, C, and D are 4 points on a circle. AEC and DEB are straight lines. Triangle AED is an equilateral triangle. Prove that the triangle ABC is congruent to triangle DCB. So these are some of the things you look for when you want to compare if two triangles are congruent. So triangle congruence. You can use side, side, side. That means 3 sides are the same. The triangles are congruent. That's one pair of sides are the same. Second pair of sides the same. Third pair of sides the same. So they are congruent. 2 triangles, side, side, side. Another way to know if 2 triangles are congruent, you can do side angle side, SAS. One side is the same for both of them. The next side is the same for both of them. And the corresponding angles are the same. So 2 sides and 1 angle are the same. Or you can have angle side angle, ASA. These top angles are the same. One side is the same and another corresponding angles the same. Or it can be angle angle side. 2 top angles are the same, another 2 angles the same, and another 2 sides the same. So those 4 different things can show that 2 triangles are congruent. So we're going to try and look for those in that question. So we can see here this triangle 60, 60, 60 is an equilateral triangle. These 2 angles are vertically opposite. So they are 60 and 60. Now we can use angles in the same segment. If you use this line there, that means if this one is 60, this one is 60. So the 2 blue angles, 60 and 60, the 2 angles in blue are the same, using angle in the same segment. If you see that there, that is 60 and this one is 60. So the 2 blue angles are the same. If I use this same on the same arc, and if you turn and use on the other side, using this side, you can use this line there. That means these 2 angles are in the same segment. The 2 red angles are the same, 60, 60 angles in the same segment, because we are going from that side. We're looking from that arc or this line. So these 2 angles are in the same segment. So the 2 red angles are the same, 60, 60. The 2 blue angles are the same, 60, 60, from angles in the same segment. And this 60 and this 60 are the same from vertically opposite angles. So some of the things you want to consider are angle ACB and angle ADB. Angles in the same segment are equal. Angle DBC and angle DAC. Angles in the same segment are equal. Angle ABD and angle ACD. Angles in the same segment are equal. So it's just to look at the 2 blue angles are the same, the 2 red angles are the same, and the 2 yellow angles are the same. If you look at the arc from that side, 2 blue angles are the same, 2 red angles are the same, 2 yellow angles are the same. And then another thing is all the angles of 60 degrees in the triangle AED. It's called an equilateral triangle. And BC being common to both triangles, BC is common to both triangles. DB is equals to DE plus EB, or AE plus EC equals to AC, the sides of an equilateral triangle. So the condition for congruency is two angles and a side. So you can say ASA or SAS or AAS. So two angles and a side are the same. That's why they are congruent.